My name's Dave. This talk is called The Hardest CTF I've Ever Done, aka My Experiences Reverse Engineering in MMORPG. If you guys didn't get enough game hacking, then I've got good news. If you guys have enough game hacking, then I've got good news because I got more game hacking. So a little bit about myself. My name is Dave Kukfa. I'm a senior CSEC student at RIT. This is my last semester here. I like AppSec and reverse engineering, and I have a blog which I'll be posting this slide deck on after the conference, and I'm also on Twitter if any of you are Twitter enabled. So a little bit about what we're going to be talking about today. This whole project is basically an ongoing project I've had for the past 2 years to reverse engineer a dead MMORPG. So I'm going to kind of go over like the game itself, what a server emulator is, or like a private game server. Go over like a high-level overview of the actual MMO reversing process, and some tools that you can use. I know Nick just touched on a few of those, but kind of go over like a whole wide range of tools that we can use to accomplish this kind of stuff. And then we can kind of dive into the technical details. So the actual like nitty-gritty details of the reversing process for my specific game and the experiences and sort of mishaps I ran into that are a little amusing from a security perspective. I'll give a little demo of the project and the work that we have done so far, and then talk about some of the legal implications of doing something like this, and then we'll have some time for questions at the end. So, a little survey for you guys before we get going. Are there any MMO players in the crowd today? Cool, a few hands, awesome. Any CTF players? Capture the flag. Cool, sweet. Any, combine the two, any game hackers? Awesome. Cool, so hopefully after this talk that should change. So talking a little bit about the project itself. The game itself is called Dungeon Runners. This was produced by game company NCSoft in 2007. So again, it's a bit older, about the same time as Nick's game actually. So the game is an MMORPG, and if anybody's not familiar with that, it's basically this huge online world where thousands of players can all interact with one another and sort of interact with this virtual sort of fantasy world. The game uses a custom engine which was actually sort of torn down and used for a bunch of different games before it became Dungeon Runners. So sort of scrapped in between and then picked up for another game and sort of handed off between different devs until it finally landed on this final project. And then the game was shut down in 2010, unfortunately, due to a lack of profit. So the game publisher pretty much just killed it off and shut down the servers for the game. The problem with this being that since this game is an MMORPG, it's pretty much reliant on those servers in order to actually be playable. So everybody has this game client, but there's really no back-end server for it to connect to, so it's pretty much just dead weight, and the game is pretty much unplayable. You can't really do anything without that server being there. So this sort of brings us to this concept of a server emulator, which is what a lot of other players and reverse engineers try to do when they get to this point of like, my game is shut down and I still want to play it. So the server emulator is basically an attempt to recreate that server backend that the game is dependent on. And this whole server, the whole entity of a game server, is actually comprised of a bunch of different smaller components that are generally referred to by a generic term of game server. So in reality, like there's lots of different components, such as like an authentication server and like different servers for different zones and stuff like that you connect to. And all of these use a custom communication protocol usually. So a lot of this isn't documented online, a lot of this is closed source and that kind of stuff. And then on top of that, there's all sorts of design issues, such as like how are you actually going to architect this thing to scale? How are you going to make this playable when there's hundreds or maybe thousands of players trying to connect to this? Like how are you going to design the database? There's all sorts of stuff that really make this a big complicated problem. So when you're actually trying to recreate this game server, the amount of reverse engineering that's involved is really, you have to pretty much reverse all of the server-side stuff that they made. And this is a very, very complex problem. So when you're talking about the actual reverse engineering process, from a very high level, it's pretty much just taking something apart to see how it works and then trying to put it back together again. And trying to do it at this huge scale of an MMORPG is a really, really long, difficult process. And it involves a lot of guess and check sort of stuff. So like, you're not going to be able to figure out every little thing and every little detail of these games, and it's more of it's like if you get something to work and you don't really know what it's doing, like I put these bytes in this protocol and it seems to work, but I really don't know what this is doing. a lot of times we're just going to have to take that and roll with it. So that kind of makes these servers kind of hacky, and they're not generally going to perform the same way as the actual game server themselves, because the game company obviously knows more because they have the source code. But generally it's like if you can get it to work, then whatever, like just roll with the punches. So from a high level, like what does this actually look like when you go to reverse engineer this? Typically you're going to start off with protocol analysis. So like we said, there are all these components on the game server, and they all use this custom protocol in order to communicate. So at this point, like our job is pretty much just trying to figure out what do the different components send over the wire. What does the game client send to the game server, and what does the game server send back in order to actually make this game function? So in order to determine this, you're going to look at the game traffic that's going back and forth between the client and server, and try to identify certain packets. So you can see, like, when I log in, these certain packets are being sent. You can sort of identify that general structure as like, okay, this is a login packet. Like this probably contains my username and password and stuff like that. And then after that, you can sort of look at the actual structure of the packet. So okay, I know that this logs me in. Like, what do these different bytes represent? Like, what are trying to identify like some common fields in the packet. Like the username goes here, the password goes here, and try and break that down even further a little bit. And then after that, we can sort of move on to other things like encryption and checksum algorithms that all go on top of all the other stuff that we have. Connection handoffs, so like you're connecting to your authentication server, and eventually, like once you authenticate, you choose a game server, you choose like a world that you want to load into maybe. You're going to disconnect from that auth server and then reconnect onto a game server. So you're going to sort of, the connection is going to switch basically between those different components, and you want to identify where that happens and why. And then lastly, stuff like serialization. So like if you have these objects that are being stored server side, like a game character, for example, how are you going to break that down into a binary representation and then send that over the wire? So that's basically your serialization process. So like down here we have this picture of example game traffic, and like the whole goal of this protocol analysis phase is basically to figure out like, okay, we've got all these bytes, like what does this mean? Like what are these bytes controlling? Like what do they do in the game in terms of like, does this have my username and password? Like is this telling me to enter the world? Like what does this do basically? Like, what are these bytes doing? So that's the goal of this phase, and this is where a lot of our reverse engineering work is going to be. So this is a very, very long point of this whole process. So after that, once we sort of identify the communication protocol, we can move on to the actual server design phase. So this is where we know how stuff talks, and we basically need to just architect this whole backend that we've been talking about and trying to reverse engineer. So, like I said, like the whole process with MMORPGs and trying to make their backend is a very, very complex sort of area where game companies will spend like years and like hundreds of thousands of dollars in order to actually make a solid, resilient game server. So again, like trying to implement this as a reverse engineer and trying to recreate that sort of magic that they've done is a very, very complex process just because there's so much stuff going on. So like I said, like there's lots of servers on the back end in terms of authentication, like your actual gameplay server, stuff that like your databases, stuff that just hosts like a single zone or like a map in the game. Like there's all sorts of different components that are on this back end, and we have to sort of re-architect this in a way that's scalable and resilient, because if people start logging onto your game, there's 100 or 1,000 players and stuff stops working, they're not going to be very happy. And the stuff that goes into this is like your actual database design. So like, am I going to go with a SQL server or a NoSQL server? Like, am I going to use an older technology or a newer technology? How are you actually going to structure your code? So like if you have a lot of like inefficient loops and stuff like that, like that's all going to basically result in lag for your players, which is not going to be very fun on their end. So all this stuff is really important, and again, this is a very, very complex sort of design that you're going to have to take into account once you actually figure out how everything talks to one another. So after that point, we know how everything's talk to one another, and we have our server built up. Like now we can basically just fill it with data. So you're basically trying to recreate that game world that was taken down on the server side. So a lot of stuff is going to be stored client side, which is good, pretty much like in the game assets. So like if you ever downloaded a game and you're wondering like, why is this like 30 gigabytes? This is why, it's because a lot of this stuff on here is stored in the actual client instead of stored on the server and transported over the wire. So a lot of this stuff is stored client side, which is really good in this phase, because otherwise you'd be doing a lot of data entry. So the stuff that you might have to end up adding back in is stuff like your vendor or your merchant inventories. Like if you talk to like a vendor, what kind of stuff do they have for you to buy? Like your quest info. When you're actually in a combat zone, like where do enemies pop up? How many enemies are there? Like how do they interact with the players and stuff like that. The actual loot and drops that come from killing an enemy. And then if you have it particularly rough, you might have to implement some other stuff, such as like how are your maps laid out. So like when you load into a zone, you might have to like specify where everything is in the map, and like there's a merchant here, and there's a vendor here, and there's a quest giver here. Like you might have to actually hard code that into the map data back on the server side. Stuff like where your NPCs are located, and also dialogue between like your NPCs and your players. Yeah.
Is this where the excessively detailed fandom wikis come in?
Oh yeah, yeah. You're gonna be cruising a lot of those for sure. So in order to actually accomplish this, there's a lot of different tools that we can use. So basically, the general bucket term is in the bolded text up here. So like your disassembler is basically a tool that's going to take your compiled machine language and turn that back into your assembly language. So that's still not at the high level like C++ code, for example, but it's going to make it sort of more human readable. So this was something that we saw in Nick's talk. So we saw x86 assembly, for example. Your disassembler is basically going to take like your compiled game binary and turn it back into your x86 assembly code. So these tools are generally referred to as static analysis tools because they're looking at the game when it's not running, just in its binary format on disk. So some tools that can do this are IDA, Binary Ninja, and there's other ones like Hopper and Radar, which are newer. So IDA is pretty much like the go-to, like sort of the gold standard almost, but it's also very expensive. Your debugger is going to do something different. So that's actually going to run your program and then look at the state as it's running. And you can sort of like step through the different x86 assembly instructions and look at how stuff changes after each instruction executes. So stuff like the current instruction that's being executed, the actual values of the registers and what's in memory, all that stuff is going to be changing as you run your program, and you can use your debugger to take a look at that. So on the other hand, this is called dynamic analysis because the program is actually running and it's dynamic and it's not just sitting on disk. So you can actually see what happens when the program is executing, so when your game is running. And some tools for this, again, IDA has a built-in debugger as well. There's Ollie Debug, which is Sonic using. There's GDB, and then x64 debug for Windows. And then lastly, your packet sniffer, basically you want to take a look at that traffic that's going across the wire so you can do your protocol analysis. So you're pretty much going to need a packet sniffer in order to look at what's actually going on over the network. So common examples, Wireshark, I'm sure a lot of us have used. There's TCP dump as well, and then Fiddler. And then your hex editor is for actually looking at and manipulating that binary data that's sent over the wire in hexadecimal format. So there's HXD for Windows, which I really like. There's Vim, which has a hex mode, and there's also Hextheme for OS X. So now we can kind of dive into the actual technical sort of going details of this whole process. So when I was starting out, I pretty much just had this dormant game client. So the game client was distributed with the game. There's pretty much no server for it to connect to, so it's pretty much just like, here you go, use this game client to pretty much recreate the server side. So the actual game server itself, the communication protocol that it used was not public. It was all proprietary, like private information that was not publicly documented whatsoever. There's an important distinction between the game server and the authentication server for this, which we'll be talking about in a bit. But the actual game server, where like pretty much the most of the actual game was implemented, was not public information. And there were no packet captures also, so I didn't have like a known good reference of like, here's what this packet should look like, and here's how you should recreate this on your server so they can handle this information. There's really no known good examples of that, which again makes things very, very difficult because that's pretty much what a lot of existing game server emulators are built off of. So somebody would basically open up Wireshark and they'd have their legitimate client, their legitimate server, and they'd look at the traffic that goes back and forth, they'd see the responses that the server would send, and they try and emulate that by like writing their own program. So they try and emulate those known good server responses, and when we don't have those, then it's basically a lot more reverse engineering work and a lot more time it takes to actually get to that state. But on the other hand, we did have the debug symbols for the binary. So like if you look over on that far right window over there, the functions window in IDA, you'll see that there's like 34,000 functions Those are all loaded from that PDB file over there that basically shows what the functions were called when they were compiled and at what memory locations they're located at. So this is very, very helpful because we could actually see, what the actual game programmers name their functions. We could get a little more information about the binary itself. So, this is all very, very important from a reverse engineering standpoint, and I haven't really seen many other games that actually ship with these debug symbols. They're normally removed so that people can't actually reverse engineer their games. So I don't know if this was just a mistake or if this was, just like a gift to people who were trying to reverse engineer this thing or not, but they're there, so we're happy. And then there's also, the other thing that's important is the verbose log output of the game itself. So if you look down at the bottom there, we can see that the game actually logs what functions are doing what for some important functions of our game. So we can see over here, there's this internal game state that's changing from 0 to 1 and then 1 to 2 as we're actually logging into the game. So we can see what function is actually causing those state changes. And this sort of logging format is very, very useful when we're trying to debug issues, which we'll see a lot in the future too. So kind of starting out, I really didn't know much about reverse engineering and kind of where to even take this project on from the get-go was what I was trying to figure out. So first off, when you're trying to run the game binary, it would only run if it's launched from the publisher's proprietary little game portal application. So basically, this thing would just load up and it would show a bunch of different games that the publisher has, and you'd click one and you'd hit play, and then the actual game binary for the specific game. So for Dungeon Runners, would open up from that. So the actual game launcher itself didn't run because it was trying to connect to these HTTP endpoints from 10 years ago, so from 2007, and then since taken down. So of course the game didn't run from this automated little game portal thing that they had. So in order to get around this, I basically just threw the binary into IDA and I was taking a look at the command line options. So on the bottom here, I found this thing on the string is called ran from launcher, which basically just is passed from the actual game launcher to the game in order to say hey, this was actually run from the NCSoft game launcher. So if you just supply this within the Windows command line arguments, the game boots right up. So that's cool, I got the game running. The other problem was the game was trying to connect to this auth.dungeonrunners.com endpoint, which was pretty much taken down after the game went down. So again, trying to connect to stuff that just doesn't exist. And in order to get around that, there's this dungeonrunners.cfg file, which is in the config files of the game, within the game assets. And you can basically just change that over to a server on your LAN or whatever, the place where you want to host your private server. So it's cool because you actually don't have to patch the binary using IDA or something like that. You can literally just change this option in the config file, and then when the game runs, it'll try to connect to whatever you specify in there, which is cool. So at this point, we know how to open our game and we can get it to connect to our local server, but now we have to actually understand the protocol it's using, which was that really arduous step that I was talking about in the beginning. So again, where do I even take this on? There's this protocol that I have no idea what it's doing. I can't really take a look at any known good packet captures. Where do I go from this point? So again, I threw the binary in IDA and I was sort of looking through the functions, and I kept seeing this recurring trend of these functions starting with lin, L-I-N, and L2. And these functions are located right next to the actual authentication function within the binary. So I'm sitting here looking at these thinking, all right, there's got to be some importance to this. This looks like these might be connected somehow. And I did a bit of Googling, and it turns out that these were referring to another game called Lineage 2. I don't know if anybody here has heard of that before, but this is another more popular MMO that's made by NCSoft. So this was released in 2003, and it's actually still being developed. So this game has had several different releases over the years, and each of these have had a different protocol for each different release of the game. But the good thing is that these have all been reverse engineered and publicly documented. So the protocols for each of these different releases is all publicly known. So I'm sitting here looking at this thinking, okay, we've got two different games, both by the same publisher, and I'm seeing these references to Lin and L2 within Dungeon Runners. Maybe Dungeon Runners could have borrowed that authentication server from Lineage 2. So, my sort of thought process here is what if I just found an early version of that server, an early private server from around 2003, and just stand that up locally and see if that actually worked with my game and trying to reverse engineer. So I set off on Google again, like trying to pull through all these old files from like 14, 15 years ago, trying to find a Lineage 2 server from around that same time period, which was a total pain in the ass because all those links were like long dead from like 10 years ago, and it was really, you know, a lot of just throwing stuff into like archive.org and trying to pull all these old like files from history, and it was a total pain. So archive.org is a lifesaver. If any of you are trying to reverse engineer an old game, keep that in mind because it's really, really helpful. And I ended up finding this legacy auth server written in Java from like 2004. So I downloaded this ancient JDK and got it all set up on like a local machine on my LAN. Feeling pretty good. So usually when we run the game, we're just used to seeing this connecting the world thing where it sort of hangs when it's trying to connect to like I think I just set up like a basic TCP listener here or whatever. So normally it would just like conk out at this point because it doesn't have an actual auth server to connect to and just hang here. But when we actually stand up this Lineage 2 server, we get a little bit further. So we get this connecting the world screen with a blank list of worlds to connect to. So like after getting here, I was just freaking out at this point. I think I like almost like flipped my chair over and I was like running around the house and stuff because this took like a few weeks to actually get to, and seeing this actually work was like really, really cool. So you know, this was a really good sign. So we're actually starting to make some progress here at this point. So it turns out that Dungeon Runners did actually use that Lineage 2 authentication protocol. And it turns out a bunch of other NCSoft MMOs actually did the same thing too. So yeah, like lots of other games have just pulled this Lineage 2 server and just like chunks of right into their game as well, which is really interesting. Oh, sorry about that. So anyway, like Dungeon Runners and the Lineage 2 server did share the same protocols, which was cool. The problem was the Lineage 2 server was like obviously made for Lineage 2, right? So it wasn't like directly 100% compatible right out of the box with Dungeon Runners. So like we saw before, some things just didn't work because Dungeon Runners did things a little bit differently, but they still used the same protocols. So like we saw an empty worlds list before, that was just one of the things that didn't work right out of the box. So instead of like trying to sort of troll through this like 14-year-old code base and change all this Lineage 2 like Java code, I decided like, how about I just build my own auth server and like re-implement these protocols in a way that I can understand better rather than trying to understand this whole code base. So the good news was, like I said before, like all these protocols for Lineage 2 have been reverse engineered and publicly documented before. The bad news was the only version I found was entirely in Russian. So this was a little interesting. Again, like this is all from 2007, and I pretty much just had to throw this into like Google Translate and just try and like do the best that I could with it. If anybody knows Russian, please send me an email because I'd be interested in talking with you. But yeah, after a bunch of Google Translate, I was like basically just able to take these protocols and just make my own Python version of the server. So basically, the client would log in, and the server would send the client a list of game worlds or game servers, and then the client would pick one and connect to it. The problem here was the actual authentication packets from the client did not exactly follow this Lineage 2 protocol spec. So the problem was when the client basically sent over its credentials, you basically couldn't decrypt those and to look at the plaintext version of the credentials based on the information provided in the L2 spec. So when you're trying to actually authenticate your players, like you're going to need that information in order to determine, like, you know, is this player actually who he says he is? So the problem here is just the username and password fields within the protocol were just decrypting to like these unintelligible like blobs of data. So something was definitely up, and like basically I needed to figure out how Dungeon Runners was doing their encryption because it strayed a little bit away from the Lineage 2 spec. So again, like back to IDA, sort of through the binary in there, was poking around for functions that might have helped us. Again, this is where those debug symbols showed up because without those, I basically have no idea that this function was called send login. So I'm taking a look at these functions, and I find this send login function, which again looks like it'll be pretty helpful for us given our predicament here. And within that function, there's a call to des write block within the L2 des encrypt class. So there's a few things that sort of jump out here. Like first of all, des is an encryption algorithm, and if we're calling des write block, then maybe something within our login function is encrypted with des. Probably like the username and password. So sort of kept following down the rabbit hole a little bit more, and I was looking at the functions that are within the L2 des encrypt class, and I found this des key init function. So since DES is a symmetric key algorithm, the same key that's in this client is going to be in the server as well. So if we can pull the encryption key from the actual client, we can just pretty much re-implement that in the server and to be able to decrypt our credentials. So I'm looking at this DES key init function, and I found this code block that basically kept referring to this byte array here. And it would basically just pull a byte out and like add it to, I think it was like trying to dynamically build a string or something, so it would pull a byte out and add it to the string and then loop back around and pull another byte out, another byte out. So it kept referencing this byte array at this address here. And I keep thinking like, okay, this has got to be our key. Like, if this isn't the DES key init function that's pulling these bytes out and trying to build a string, like this is probably the encryption key. So I go to this byte array, and I find the word test in caps with 4 null bytes. And it turns out that this was indeed our encryption key for the That was a bit of a scare, but again, like we're rolling with the punches here. Back in the day, like security for this game probably wasn't the utmost priority, so whatever. Like I throw this in, and it starts working, which is really cool. So, kind of recapping what we found out so far. The algorithm is DES. Our symmetric key is test with the 4 null bytes. Does anyone want to take a stab at the mode of operation, sort of given our track record so far?
ECB.
Close. Oh, yeah, ECB, yeah. Yes, so for anybody who's not familiar with ECB, it's pretty much, bad, because if we take a look at this image down here, so this is the Tux Penguin. On the far right, we encrypt using a mode of operation, pretty much anything other than ECB. But if you look at the middle one, this is this image over here on the left, but encrypted with the ECB mode of operation. So the problem here, we can sort of see that like this is clearly like the Tux Penguin. And the problem with this is you can basically pull out different patterns essentially within the encrypted data. So you can pretty much get like a pretty good idea that this image that's being encrypted is the Tux Penguin. So again, like it's not the best from a security standpoint, but again, we're rolling with the punches here. We're just trying to get our game working. And the block size for the DES algorithm is 8 bytes or 64 bits. So given our lineage 2 protocol spec, this sort of presents another interesting problem here. So if we take a look at our actual login specifications within the protocol, the max length of the username can be 14 characters, and the max length of the password can be 16 characters. So for a total size, if we max both of these out, it's going to be 30 characters, and since the game uses ASCII encoding, then that's 30 bytes. And our block size is 8 bytes, so that means we can encrypt data that's in chunks of 8 bytes pretty much, so 8 bytes, 16 bytes, 24 bytes, and 32 bytes worth of data. Basically, if it's divisible by 8, we can encrypt it using this block cipher. So the problem here comes that, basically our credential length is not always going to be divisible by 8 perfectly. So that sort of creates this interesting scenario of like, what are we going to do when it's not a perfect multiple of 8? So you might think, like, at this point you would just round up and maybe add some extra bytes to the end to actually get to that block of 8 so we can encrypt the whole thing. But it turns out that this was also not the case. So if we have our 14-character username here and a 16-character password for a total of 30 characters, these will get encrypted by the game, and I took this snippet to show what's being sent over the wire. So if you look at the first 14 characters here of the username, basically just a bunch of random stuff. There's some non-printable characters and like a copyright symbol and stuff that looks nothing like our username. So if we take a look at the password, we're going pretty strong. We got like a non-printable character and like a paragraph symbol and stuff. We're going pretty strong up until byte number 24. And then after that we see RPASSW, which might look a little familiar because that's the second half of our password. So the issue here was the game literally just let the extra like spillover from the password just hang open in like plain text as it was sent over the wire. So it sort of took me a while to figure out what was going on here. And it took me a while to reach this conclusion because I was thinking like, all right, there's no way that this could actually be the case. But it turns out like, here we go. So yeah, the password just sort of hangs out over that 24 byte range, which is again kind of interesting, but like whatever. So at this point, we added this onto our server, and at this point, like pretty much the authentication server is largely like a solved problem. So again, like the player would log in, the game server or the auth server would send the list of game worlds. and the player would basically connect to one, and then after the player chose the world that he wants to connect to, we basically disconnect from the auth server and then connect to the game server. So the issue here is the game server uses a whole different protocol set that doesn't mimic L2. Like, this is a whole new, basically custom proprietary protocol that they use for the actual game server. So again, we're kind of back in that beginning stage of like, all right, like, where do we even get started on this? Like, this is a whole new, we pretty much can't cheat from Lineage 2 now. Like, we kind of have to just reverse engineer this whole protocol and then implement it as a whole new separate thing from what we've already learned so far. So starting out, I pretty much just tried a basic approach of like just trying to copy the protocol of Lineage 2, which again, like, because they're two separate protocols, didn't really get us too far. But the cool thing was the actual game logs that were very verbose and told us a lot of information actually printed out what was going wrong as we were trying to use this wrong protocol. So as an example here, we can see that we're basically trying to log in, and the game basically just cuts our connection because packet size is 3277056 exceeds the max size of whatever, and the game closes the connection. This is all stored within the game logs. So the importance of this is we can basically use this to figure out like what is going wrong in our server as we try to implement that, and then to sort of fix these problems that we're having and work out like the correct structure of the packets and try to figure out the communication protocols of this unknown game server. So like, for example, for this specific issue, we see this number 3277056, and if we change that to hex, then we get 320100, and we can basically look within this this set of bytes that we're sending from the server side and try and identify that 3-byte little chunk, and then see like, okay, what if I modulate like this value, change this to like the exceeded max or whatever? What if I just put some data in front of that and put some data after that? You can basically just sort of modulate things a little bit and then go back, run it again, see like, okay, is the game working now? Like, what information do we get in the logs? And you can sort of do this guess and check back and forth. So again, this isn't the most efficient process of trying to reverse engineer this game, but it's a way to make progress, and like when you don't really have anything else, this is like a really, pretty much like your only option, right? So you kind of get going in this guess and check mentality, and you can basically work out like the protocol from that point. But the bad news is like it's not always that easy, and you won't always have that information in the logs in order to rely on to work out your protocol. So like sometimes the game will just not log anything when it has an issue, and it'll just hang like a certain phase, which we'll embarrassingly enough see in the demo. But the game pretty much just doesn't log everything within the logs. Sometimes it'll just say, okay, I don't have what I need, like I'm just going to stop, or I'm just going to wait for you to send the right thing or something like that. And when you're not actually sending the right thing, it'll just wait there for hours. So oftentimes you'll need to just take your debugger and just dive in and see like what's actually going wrong. So when you sort of have a large game binary like this, like my game, for example, is like I think 6 megabytes for a binary, which like compared to some other ones being like 100 kilobytes maybe, or a few kilobytes depending on the size of the application. This is like huge. Like this is a really, really big binary, of course, because there's like 34,000 functions. So the sort of problem here is like, where do I even, there's all this like attack surface of the binary. Like where do I even dive in? Like what kind of functions do I look at? And my methodology for approaching this was pretty much just like identify the functions that are related to the issue that I'm having. So like if I'm having an issue logging in, like I look for the the send login function or stuff that's login within the function name or something like that, and just try and pick out like, okay, this one looks fruitful, and this one, and just sort of generate that list of like, all right, these are functions that are probably related to the issue I'm having. So from there you can sort of sift through like in your disassembler and sort of go through like static analysis and just see like, all right, what do these functions actually do? Like, is this just a wrapper around like a basic Windows API call, or is this like a really complex function with a bunch of switch statements, or like, what is the actual code for these functions? And from there, like, you can sort of ask these questions like, okay, is there a possible like check or a condition within this function that I'm failing or that I'm not meeting? Like, is there a switch statement that I'm not sending the right value to, or something like that? And you can sort of find like, okay, is the game looking for an expected value here? Like, am I sending a 0 when it wants a 1 or something like that? And you can get all this through a combination of static and dynamic analysis. So at this point, once you actually identify, like, here's some potential problem points, basically just set a bunch of breakpoints within the actual debugger, and then just run your game and see, like, okay, what are the actual values that I'm sending from the server? And, like, how do these compare to the expected values that the client's looking for? And you can sort of, again, go back and forth and see, like, okay, if I go back to my server code and I modulate this value, what's actually going to come with that on the client? Like, am I going to pass this check? Am I still going to fail? And just sort of, again, go back and forth and try and figure out, like, okay, what do I need to change? And is this working? Is this not working? Do I need to find another method? And stuff like that. So again, like, very, very time-consuming process. So this going back and forth thing is generally, like, inefficient, but it's pretty much all you have at this point. So again, like, if you're wondering why, like, some of these projects take 3, 4, or 5 years to even get off the ground and to get, you know, a basic, like, functionality where you can log in and, like, move around with your character and stuff like that, just because this process takes a very long time to sort of figure out these issues that we're having. And then again, like, if the high-level code that the developers wrote was really disorganized and sort of spaghetti code from the get-go, this is a total pain in the ass to reverse engineer, and it makes your job that much harder. So you're going to be very, very familiar with these steps if, you know, the developers have sort of shoddy code that they shipped out with their game. So eventually, after doing this for a while, I was basically able to identify these 4 different packet structures that the game used to communicate. So these are generally the same with small sort of tweaks or changes in between each. So an example of this is, like, we have 1 byte that basically identifies our packet type. 3 bytes of, like, unknown, I don't know what the hell this is doing, but whatever I put there, it seems to work, so I'm just going to leave it. And again, that's a really common trend for these kind of projects. Like, if you don't know what it's doing and you can't figure out, but it's working, like, sometimes you just got to roll with it. 4 bytes for the compressed size of our packet, actual packet data below. 4 bytes for the uncompressed size, and then our actual compressed packet data below that. And it uses zlib with default compression, I believe. So again, like, there were sort of small, subtle changes in between each of these, but it generally followed this one variant. So, like, you might have, like, one field before the other or something in a different variant. But the interesting thing about this was your actual packet type was basically, like, you could send whatever packet data you wanted using whatever packet type you wanted. But the interesting thing was that packet type was tied to a specific packet structure. And what I mean by that was, like, let's say you're trying to use packet type 0x2 to send your data, but that can only be used with, like, packet structure number 4, for example. So it's tied to that specific packet structure, which was kind of interesting, but yeah, kind of worth noting, I guess. But the actual meat of the protocol was in these, what's known as channel types, and what was actually the game symbols is channel types. So basically, like, your actual packet data, your payload at the end of that, will start out with a 1 byte channel type, which basically specifies, at least what I think it specifies, is where you want to send that actual packet within those multiple components of your game server. So again, like, if there's multiple servers, such as, like, your authentication server and your game server and your zone servers and stuff like that, there's pretty much just this one, like, almost load balancer, you think of it as, at, like, the perimeter of the game server network, and that would basically take all your packets. And what I think it would do at that point is look at that channel type and decide where to route it internally based on what channel you're trying to send this data to. So again, from sifting through the game binary, I found a bunch of different channels that can be used for this. So the important ones to note here are your character manager client, which is basically handles your character selection. Your client entity manager, which manages, like, your game entities when you're playing the game, so, like, other players and monsters and vendors and stuff like that. And then your zone client, which is basically for entering and leaving different zones in the game, and you can sort of think of those as maps. So after that, you can basically send the actual data that you want to communicate to that specific channel. So these usually start out with, like, a 1 byte identifier for what type of packet or what type of data we'll be sending. So, like, for example, if you look at our character manager client from before, there's all sorts of different basically types of packets that you can send it. So you can send, like, 0x0 for connected, basically, like, hey, I'm here, I'm the client. There's a disconnected on the other side of that. There's character created, which is basically, like, you create a character on your game binary and you try and send it over to the server for storage. And there's got character, which is basically on the other side of that, so you log in and you get your list of characters back to the client. And there's another one for, like, entering your actual character creation screen. So these are actually followed by the actual data that you need for that specific packet. So, like, for example, for a character created, like, you would send your 0x2 for, like, I created a character, but then you would also send, like, your actual character in serialized format, because like you need the server to store that, so that when you log back in, your character is actually like there on the server. It doesn't just get deleted. So after sort of doing this enough and piecing enough of these different channel types together, I basically simulate like some very basic game functionality. So in terms of like character serialization, sending characters over the wire, that one took about like 3 weeks to do, which was just a lot of reverse engineering, very frustrating. Creating a character, so you create a character on the client and send it over to the server, and the server stores it, and then actually sending the character list back from the server to the client. So obviously, like this isn't enough to make like a full game out of it. There's still a lot of work to be done. So actually, like loading into a zone, creating your game entities, so like other players and like other monsters and stuff that you would be attacking when you're actually in the game. So like you can't have a game with just your one player running around pretty much. And then comes the problem of actually like synchronizing multiple clients within the actual game environment. So again, like if you're just playing by yourself, and it's not going to be as fun. And like the whole point of an MMO is you have multiple different clients. So you have to sort of handle that communication between the clients and the server and stuff, and make sure that everything's in sync, which again is a whole nother problem just because of how complex these games are engineered. And then on top of that, just like properly architecting the server that we talked about before. So we have to actually like implement these this sort of protocol and this like communication structure in every like single server on the back end in order to be like scalable and resilient, and to basically like not have players lag all the time and stuff like that. So I thought I'd sort of show the progress I've made so far at this point. So again, there's not a whole lot of stuff to show, but there's very basic sort of like proof of concept here. So if you open up our Dungeon Writers config file, we can see that I basically redirected our authentication server to that local IP address that's on basically like a VMnet within VMware. So again, this is all like local, and it doesn't try to connect out to that old like authentication server. And then over here, we'll just tab over to that server, and we can start, both of these are Python scripts. So there's a login server for handling the authentication, and then there's a gateway server, which is basically like the game server at this point. So both of these are listening on separate ports in the same box. So if we go over here and launch our game client, we're going to get this nice spooky skeleton up here, and we're going to log in with our example credentials, and we're going to see this world list show up. So if we go over here, we can see that username and password that is provided in the authentication server. So we'll choose world 1, and the game is going to send us our list of characters, which at this point is this nice, friendly, half-naked man. This took about 4 weeks to actually get to this point, so again, like not much to show for it, but this is really confusing to try to figure out the actual serialization. So if we look over here, we'll see that this huge data block over here was basically that character that we just sent from the server over to the client. And there's basically like this little people live over here that just sends this empty data packet over here that just keeps going every few seconds. So at this point, we'll hit play, we'll try to enter the world in this character, and that'll basically try to throw us into the world. So I send the load zone game packet, and this is where things sort of stop. So at this point, this is basically what I was talking about before, where things will just sort of hang there, and you don't really know what's going on because it's not going to give you any error messages, or it's not going to give you any, anything in the logs or anything like that. And I'm basically just been in like no man's land on here for a few weeks. So I basically try and send all this information over here to try and prompt it to like, hey, how about you actually like load in that world that I was telling you about before? And it'll just sit there and do nothing. So again, like this is one of the problems of the whole like reverse engineering thing, is when you don't really know why things are going wrong, but like they are. So yeah, at that point, like that's pretty much the extent of the server that I've created so far. So again, it's not much, but it's a work in progress. So. So now that we've shown the minimal fruits of my labor here, we can talk about how I'm going to get sued for it. So in terms of like game companies, they usually don't like these kinds of projects. So when it comes down to actual game server emulators, like it's a huge intellectual property issue. For anybody that's in the legal space, that instantly raises like red flags, right? Like these companies will literally fight tooth and nail over protecting their intellectual property, which sucks if you're like a college kid who's trying to reverse engineer a game. So like sometimes indie studios might be more relaxed about this. Some are really cool and like encourage people to make mods and to make, extensions and like open source stuff for their games. But some are very, very opposed to that on the other end too. So it's really a toss-up of the type of game company that you're working with. So some famous examples of when things went wrong were in 2016. There was a WoW private server called Nostalrius. I think I'm saying that right, but that's basically like a huge World of Warcraft private server that had over 150,000 active users and I think 800,000 registered users that was shut down by Blizzard. In 2012, there was a MapleStory private server that got hit with a $3.6 million lawsuit. 2009, there was a WoW private server ordered to pay $88 million to Blizzard. And then in 2008, there was a gentleman who made a World of Warcraft bot, so not even making a server emulator, but just basically like a bot that Nick was talking about actually, that'll automatically play the game for you. So again, one of those sort of game hacking tools, ordered to pay $6 million to Blizzard. And the thing that sucks is all these dollar amounts is money that I do not have. So if I were to get sued, that pretty much would not end well for me, right? NCSoft particularly doesn't have too friendly of a history, so we started off in 2006 with a nice FBI investigation and home raid, and then there's a bunch of cease and desist after that for a bunch of different games. Basically the takeaway point is they really don't like this kind of stuff, and some of these have been a mix of games that are like still active and some that are shut down, so like it's sort of, both sort of sides of the story. They really just don't like it either way across the board. There's been some recent EFF exemptions, so this was around 2014. They actually landed a recent DMCA exemption in terms of video game archiving, and what that basically entailed was they wanted to reduce that sort of legal gray area or uncertainty that comes around reverse engineering games for preservation purposes, which is the real keyword here. So this isn't for creating emulators of games that are already existing or trying to steal business or stuff like that. This is basically just in order for people like me who just want to play the games that they can't play anymore because the servers have been shut down. So the sort of the kicker here was this was pretty much not intended to apply to games with persistent worlds, they call it, which is basically like the definition of an MMORPG, meaning like you log in and like you do stuff in the game and you log out, and then when you log back in, like all that stuff that you did is saved there on the server side, as well as everything else that the players did to impact the world, like the other people. So this whole persistent worlds thing is pretty much like MMORPGs, and it's like specifically not intended for that type of game. So this has sort of been debated within like the legal community, I guess, for this sort of stuff. But the general consensus is that like this exemption was not intended to cover like MMO server emulators. So again, like kind of sucks because like if you do end up in court, then you can't really like use this to defend yourself. Specifically, like in terms of my game, I've actually attempted to reach out to NCSoft multiple times and just say like, hey, can I outright like buy this intellectual property, because it's pretty much just sitting there. I don't even know if they still have it anymore, like the game server binaries and stuff like that, but it's pretty much just been sitting there locked away for like almost 10 years now and not really doing much. So there's a community of like maybe around like 250 players that were really, really dedicated to this game and want to see it revived again and want to be able to play it. And pretty much every attempt that I've made in order to reach out to the game publisher has just gone unanswered. So again, that kind of sucks because we're sort of left with reverse engineering the game, which is pretty much like the plan for the foreseeable future, just to keep sort of going down this path and trying to make more and more progress actually reversing it. One of the main things I'm trying to do is actually avoid actual piracy of game assets. So like pretty much everything I've created is just sort of mimicking that game protocol. So I'm not actually taking like copyrighted code that was owned by NCSoft, or I'm not distributing the game client. Like pretty much I don't want to wind up in like a piracy lawsuit on top of this, right? Like, so I'm pretty much trying to avoid taking NCSoft owned property and distributing that or open sourcing that or whatever. And then the other thing is my game isn't meant to be like commercial either, right? Like I'm literally doing this just to be able to play the game again. So there's a lot of servers that have sort of gotten into these huge high-profile lawsuits because they've been taking subscribers away from the publisher. They're creating emulators for games that are already running basically and that already have like a subscriber base. So when these games are still functional and these emulator communities basically take players away from that, that's when the game companies get really mad. So again, I'm trying to avoid that entirely. And then lastly, like you can kind of just hope for the best at this point. Like we've seen before, like a lot of times they'll throw a cease and desist at you, and then it's sort of a lot of times like end the progress for actually creating this project. So again, like I'm kind of hoping that doesn't happen. You know, if you see my name in like the New York Times or whatever for getting sued for like $1 trillion, then you know you heard it here first, right? So we're really trying to avoid that. So any questions? I sort of talked for like the past 50 minutes. Yeah.
So why do you like play like thousands of hours into this, or do you just like find a game that would work and do some fun?
Right. So it was honestly a mix of both. Like the last time I played this was when I was like 13, I think. So this was a few years before it sort of went down, and like I lost interest over the years. It was like 8th grade or whatever, and I was sort of looking this up like around like 2013 or 2014 or whatever, and I was like just curious, like threw it into Google, and I was like, oh, that game like shut down. I'm like, oh, that sucks. Like, that was pretty fun to play. And I kept looking into it a little more. There was actually somebody that started this project before me, and they were like, huh, like what if we just create like a server in it? And I was reading more about it, and like turns out that the person that actually started this whole effort pretty much started it and then just had to drop it because like as we've seen before, like it took way too much time, and they just didn't have that time to actually continue working on it. So I was sort of like, huh, like, you know, I'm in this whole computer security thing, like maybe I should try and figure out like how this works and see if I can like try my hand at this. So from there I pretty much just learned like, I think I still have like a bookmark in my like Dungeon Runners folder, like what is x86 assembly or something like that. I pretty much started from like that basis level and then just tried to like work my way up. So yeah, it's sort of like an ongoing project, and you know, like I said, like it's been going on for 2 years now, so like the amount that I've learned since then has like gotten like a lot, you know, higher obviously, but like I'm still trying to, I learned a lot from doing this from like a reverse engineering perspective, but also just, you know, to be able to play the game again would be really cool. A lot of it's like nostalgic too. Yeah.
You just said you've been working on this for 2 years and you just got past like the account creation, not like...
Yeah, so the thing with that is there's been a lot of, given that whole like school thing that I've been doing for the past few years as well, I don't really have a lot of time to throw into this. So like those times when I actually made the most progress of this that I ever have in terms of like actually reverse engineering like the auth server and the game server in the past like 9 months, I think, or like 6 months maybe. But either way, like it's been a lot more recently than like previously. So that 2-year date mark is basically when I looked into it and just like, huh, like I wonder what reverse engineering is. So yeah, it's kind of been like more recent than the latter, but yeah, it's been a total of 2 years. Yeah.
So you're doing this all by yourself? Any of it on the net? Anybody else interested in helping you, or is this just your passion?
Yeah, so there's been a few people that have contributed a little bit. Like I said, like there was somebody else that started and actually made some considerable progress, but then again, like he had to drop it just due to a time thing. And there's been other people that have sort of helped on, like on and off over the years, kind of. But it's mostly been like me sort of leading the efforts at this point. There's been a lot of people within like the game community that have reached out and said like, hey, you know, like, can I help you at all? And it sort of comes down to like, okay, like, yeah, like I'd love if you could help. Like, do you know anything about reverse engineering? And they're like, no, what's that? So, you know, like, there's, I'm sort of waiting for that point, like maybe when it comes to like the data entry portion or something like that, when I can sort of get more like community involved. But at this point, it's really just like a concentrated like reverse engineering, really technical problem. So it's kind of hard to get help like that, but there have been a lot of motivated people that have been interested in helping, which is nice. Yeah, Nick.
How does it handle like the map files and stuff? Because I know you're kind of stopped at like where it's loading the map, and like it's a problem where like the protocol to get it there. Do you have any of the map files?
Yeah, so the interesting thing is these are all like individually like zlib encrypt and then thrown into one huge file that's like 600 megabytes or something like that. So I've sort of like pawed through it a little bit and trying to, you know, like see what's going on. I really think it's more of like a server issue, like I'm not sending the right packet to tell it to load one of the map files, rather than like, you know, something locally.
So you haven't found out the right thing you need to send it, so it's a protocol reverse engineering on the client for us to expect.
Yeah, exactly. Yeah. And again, like it gets hard because it just sits there and just does nothing too. So it's, that's sort of where you hit that wall and you need like a, you know, stroke of genius or something in order to get past it. So, yeah, kind of difficult. Yeah.
That's kind of what I was wondering. I'm assuming that you've already had your Ollie DBG up, and when it's frozen like that, it's just waiting. What's it looking for?
Yeah, so I've kind of tried to isolate some, again, like going through that same process, trying to isolate some functions that I think might be the problem. I really haven't been able to find anything specifically. Like, there's without trying to go into too much detail, like there's a select few functions that are actually related to the actual like load at world class within the functions, and like none of those have really proven to be too fruitful. So it's sort of just like, you know, kind of been stumped for the past few months. I'm just trying to like make progress on that. So I guess my next sort of thing that I've been thinking on how to make progress with this is just to take like another game that's totally like separate from this, that might not, the protocols might even translate like one-to-one, but just sort of see like, all right, what do they do in order to load into a world? Just try and take some like high-level examples and just see like, okay, maybe I can, you know, try and find a packet like this within my game or something like that. Cool. I see people, yeah, one more question?
Yeah, from a legal point of view, since you're reinventing the server structure on your own, can you open source your code?
So it's kind of been an interesting thing. From what I've sort of researched on it, like there's really no defined answer, just because pretty much all this legal stuff is, there's really no like defining like, yes, you can do this or no, you can't until it actually gets settled in court. So there's been a few different approaches to it. There's this one guy by the name of Rink Springer that's actually done something similar to another game where he pretty much just created like, he pretty much reverse engineered the whole game, but in order to keep from getting sued, he just kept it locally and didn't release the code at all. Which again, like it's really cool that he got it working, but it kind of sucks because it's like, well, like that's pretty much the whole point of like an MMO, right? Is to be able to like play with other people. So if you can just sort of play with yourself on your own like server, yeah, that came out wrong. But it doesn't, you know, it's not as fun, right? So like there's a whole lot of different approaches that people have taken. So not really like a defined way. I see people coming in for the closing remarks, so I'm going to unplug for now, but if anybody has any questions, feel free to come talk to me afterwards. I'd love to answer any questions you guys might have. Thanks so much, guys. Appreciate it.